Okay guys, I've had some trouble in some other videos with my voice not recording well, so I've been going headset from here on out, or at least until I can figure out what was going on. Today's lesson is on converting between polar and rectangular points and equations. So we're going to both be able to take rectangular points and turn them into polar points turn them into rectangular points. We're also going to be able to take rectangular equation, put them into polar equations, and polar equations, and turn them into rectangular equations. And that's basically our goal. To do that, we're going to need a few um, equations. So one of those equations that we need is this x equals r cosine theta and y equals r sine theta. So where are those coming from? Well, let's kind of remind ourselves where polar points came from. Polar points are an r and a theta. That represents how far away from the pole, that's what r is, how far away from the pole we are. All right. And then at what angle away from a positive x-axis. So some reference point, our reference point is the positive x-axis. So that's where we get our points in polar from. So to be able to convert this back to an x and y, which is how far left and right and how far up and down we are, we just need to get that vertical distance here, that'd be our y, and we need to get our horizontal distance here, that would be our x. And this just comes back to basic trigonometry. So I know if I want to find x, let's see, I need something with r and theta that involves x. Well, I know that the cosine of theta, right, the cosine of that angle is the adjacent over the hypotenuse. That is x over r. So if I solve this for x, I'll get r cosine theta is equal to x. I can do the same thing with y. So I know that sine of theta is equal to y over r if I think about sine being opposite over the hypotenuse. So that's y over r. So r sine theta is equal to y. So that's where this formula comes from. R comes from Pythagorean theorem. To find r given x and y, I could square the x, square the y, add them together and take the square root. And to get to the theta, I'm going to have to do some inverse trig. We've talked about this when we went through our trig chapters. So how do I find theta? Well, it's tangent of theta is equal to y over x. So the inverse tangent of y over x is theta. Now that's going to be exactly true when my x's are positive. However, when my x's are negative, I'm in the second or third quadrant, and that is outside the range of inverse tangent. Inverse tangent, if you remember, only has a range between pi halves and negative pi halves. So since that's the case, to get answers that are outside of that range, when I'm in the second or third quadrant, the answer I get, I'm going to have to add pi to it to make sure I get the correct answer. So this kind of gives you some background into where these equations come from. Hopefully that kind of helps you remember them in the future. And let's go ahead and start looking at some of the problems. So this one I'm given something, I'm given points in polar, and I'd like to convert them to rectangular. So our very first one is p is 4 comma pi sixth. So the x coordinate there is, this is r, this is theta, x is r cosine pi sixth. Cosine of pi sixth, again, you need to know your unit circle. Cosine of pi sixth is, in everyone's heads, they're thinking of the answer. Maybe they're waiting on me to say it. It's root 3 over 2. So 4 times square root of 3 over 2, or 2 root 3. For y, it's going to be 4 sine of pi sixth, and the sine of pi sixth is 1/2, so 4 times 1/2, and you get 2. So my rectangular coordinate for point P could also be defined as 2 root 3, 2. What about negative 2, 135? Well, I can just do the same thing I've already been doing. X equals r cosine theta. So that is negative 2 times the cosine of 135 degrees. Cosine of 135 degrees is negative root 2 over 2. So my final answer is positive root 2. Why? R sine theta. So I've got negative 2 times the sine of 135 degrees. Sine of 135 degrees is positive root 2 over 2. So you end up with negative root 2. So point Q is root 2, negative root 2. Just to make sure about this, let's just kind of think about this from, if I'm going 135 degrees, but up in the negative direction, that'd be going this way, and 2 spaces out, and I'm thinking about where that is. That's in the 4th quadrant. Is root 2, negative root 2, in the 4th quadrant? Yes, it is. I must have done something correct. Okay, so with these, you should be able to kind of think about where the point should be so you can come to your conclusion about whether or not you're ending up with the right thing. All right, v is 3 comma negative 120. X is going to equal to 3 cosine of negative 120 degrees. If you have a hard time knowing the cosine of negative 120 degrees, you could always get a coterminal angle. So that would be 240 degrees in this case by adding 360. So if I think about that, and I'm going to try to find the cosine of negative 120 degrees. Cosine there is going to be negative 1/2. So I've got 3 times negative 1/2, or negative 3/2. Y is equal to 3 sine negative 120 degrees. That's going to be 3 times negative root 3 over 2, or negative 3 root 3 over 2. And so V is negative 3/2 negative 3 root 3 over 2. Last but not least, point D is X and Y. You might want to pause the video and try this one on your own first, see if you get the right answer, and then unpause it and see if you get the same thing as me. I'll give you a second to get to the pause. Alright, so that's going to be negative 2 times the cosine of pi thirds. That's negative 2 times cosine of pi thirds is 1/2. So negative 1. And y, negative 2 sine of pi thirds, which is negative 2 times root 3 over 2, or negative root 3. So we end up with negative 1, negative root 3 for D. Alright guys, that is the first set of problems converting from polar to rectangular. Alright, so let's see what it looks like to go the other direction. Let's see what it looks like to go from polar to rectangular. So to do that, I'm going to need the things that say r is the square root of x squared plus the y squared, and theta is equal to the inverse tangent of the y over the x when x is greater than 0, and is the inverse tangent of the y over the, oh my goodness, over the x plus pi when x is less than 0. Alright, so let's see. My x here is positive, so I already know which one I'm going to use out of those two things. Let's find the r first. That's the square root of the x squared, 1, plus the y squared. That would be negative root 3 squared, or 3. That's the square root of 4, or 2. So I've got 2, comma, theta is going to be the inverse tangent of negative root 3 over 1, or negative root 3. So what I'm trying to think of is, what do I take the tangent of that gives me negative root 3? So I got to think about first, where is tangent negative? Or where tangent is negative in the 4th quadrant in this case, because remember we're dealing with a positive x value. And then if we're trying to think about it, tangent of theta is always the y over the x. I need the y divided by the x give me negative root 3. If I don't have my unit circle well memorized, that can be a challenge. What I'm really looking for here is when is it negative root 3 over 2 over positive 1 half, or positive root 3 over 2 over negative 1 half. Well, for the lengths here, that's kind of the things that I would know. So when from a similar triangle perspective. So in our case, we're dealing with the negative y, positive x. So when do I have negative root 3 over 2 and positive 1 half? So for my x to get a positive 1 half, I've got to be at a pi thirds. This is going to be negative pi thirds. So my final answer is 2 negative pi thirds. If you have trouble with this, guys, you probably really need to work on your unit circle. You really need to work on going back through and memorizing that unit circle. What about this one? All right, r is going to be equal to the square root of 9 plus 36, the square root of the negative 3, or the square of the negative 3 and the square of the 6. That's the square root of 45. The theta, on the other hand, my x is negative, so I'm going to be inverse tangenting 6 over 3. So what's the inverse tangent of 2 in this case? But I'm going to be adding pi to that answer. So I'm kind of trying to think of when do I take the inverse tangent and get 2. That's really what I want to kind of come up with here. So I'm thinking through how will I end up with 2. So let's see. And I'm going to get not one that I know. It is 63.43 degrees or 1.107 radians. So I'm going to put it in degrees, 63.4 degrees. So in this case, we end up with the point T is root 45, 63.4 degrees. All right. Now let's try to identify these graphs, and then let's try to write them in their polar form. So these are rectangular, then we're going to try to write them in polar form. This equation here should give you a memory of x minus h squared plus y minus k squared equals r squared. This is in fact a circle centered at h comma k with radius r. And so in our case, we have a circle whose center is 4, 0, and radius is 4. So we got to convert that thing. Well, how do I convert that thing? I got to get rid of the x's and I got to get rid of the y's. To get rid of the x, I'm going to replace x with r cosine theta. To get rid of the y's, I'm going to replace it with r sine theta. This gives me, when I square this out, r squared cosine squared theta minus 8r cosine theta plus 16 plus r squared sine squared theta, when I square out the second term, is equal to 16. Subtract the 16s from both sides. Then I end up with r squared cosine squared plus r squared sine squared theta minus 8r cosine theta is equal to 0. If I add the r cosine theta to the other side, then I should be able to factor out an r squared on the left, which leaves me with cosine squared theta plus sine squared theta. Remember our unit on trig? Sine squared plus cosine squared is a special friend of ours, and we can do something with it. So I end up with this. Sine squared plus cosine squared is 1, which leaves me with r squared is equal to 8r cosine theta. Divide both sides by r. So r will equal to 8 cosine theta. If you remember correctly, one of the types of circles we had in the last section was an a cosine theta, or that number in the front, that 8 in this case, is the diameter of the circle. All right, this next one, y equals x squared. Well, that's just a parabola. Everybody is fine with that. All right, so now we need to convert this. Well, again, y is r sine theta. X is r cosine theta. It's going to be all squared. So we have r sine theta is equal to r squared cosine squared theta. If I divide both sides by an r, that leaves me with sine theta is equal to r cosine squared theta. If I divide both sides by cosine squared, that gives me the sine over cosine squared theta is r. I can do a little simplification. I don't have to here. Sine over cosine is tangent. 1 over cosine is secant. And we get r is tangent theta secant theta. That would graph a parabola. All right, so now we're given some equations in polar form, and we want to try to write them in rectangular form. This particular one, a theta equaling a constant, we talked about that was a line. What about r equals 7? That's a circle. What about negative 5 sine theta? That's also a circle. So we've got these three different equations. I'm going to try to convert them. Theta is equal to the inverse tangent of y over x. So I'll get that back into y's and x's, which means I have to tan both sides. That'll give me y over x is equal to the tangent of pi sixth. Tangent of pi sixth is 1 over root 3, or root 3 over 3. So y would be equal to 1 over root 3x. That is in fact a line. R equals 7. Replace r with the square root of x squared plus y squared. Square both sides, get x squared plus y squared is equal to 49. Boom, circle, done. R is equal to negative 5 sine theta. Ooh. All right, what to do about this one? Well, I want this to be in full rectangular mode. I could come in here and I can replace my r with the square root of x squared plus y squared. I can come in here and I can replace sine of theta. Ooh. Geez. You know what? I don't have something that's just sine theta. I have something that says r sine theta. Man, if only there were an r there, right? Well, what if I multiply this equation both sides by r, so I can get r squared is equal to negative 5r sine theta. This would tell me that r squared is this x squared plus y squared, and this right here is y. So that gives me x squared plus y squared is equal to negative 5y. If I add the 5y over, I get to here. And now we're just going to work on completing the square so we can make it look like the form the standard form of a circle. So I've got my x squared plus y squared plus 5y plus. To square this thing, what am I going to do? Oh, geez. Well, I half it, 5 halves, square it, get 25 fourths. To do that, I got to put 25 fourths on the other side to keep this thing equal. Then when I factor that gives me y plus 5 halves as my perfect square. Boom, there we have it, our circle. All right, well, guys, we have done it. We've successfully completed this section. Like I said, as always, if you guys have any questions, if you guys need some help with something, feel free to contact me. I'll be happy to try to help however I can. Hope you are all staying safe, and take care out there.